objective today is to understand the role of enzymes in chemical reactions, what they do, how they augment the reactions, and then we're going to go ahead and talk about how those are regulated. So how do we regulate enzymatic reactions? Now we know an enzyme is basically a catalyst for a chemical reaction. It's going to make that reaction go faster. It's going to decrease the amount of energy that the reactants require in order to undergo the reaction. Right, so when we think about the word catalyst, it's something that's speeding it up, making it easier to happen, or making it more likely. Okay, and so enzymes basically decrease what we call the activation energy of the chemical reaction. And just to talk a little bit more about what the activation energy is, this is how much energy is required by the reactants in the reaction. Right? Think about, let's say, proteins. Let's say we're building amino acids and we're taking an enzyme because there's an enzyme required to actually link those amino acids into a peptide, which we talked about last time. And so in order to have those peptides being created, the enzyme is going to come in and make that reaction go a little bit faster. Right? And so those reactants, which are going to be amino acids, are going to require just a little bit less energy because the activation energy has been lowered. Okay, now enzymes will bind to a reactant, also called a substrate, and then there's some sort of shift that happens, and we end up with our product plus the enzyme on the other hand. So this equilibrium reaction represents what the enzyme will do in that chemical reaction. Now we want to bear in mind that these double arrows mean that this reaction can take place in both the forward direction as well as the reverse direction. So you can go from products to products to reactants or substrates, and you can go in the opposite direction as well, from substrates or reactants into products with the help of the enzyme. All right, let's talk about the activation energy barrier, and let's just illustrate that. Okay, so let's remind ourselves here the components or the players in this. That's going to be the reactants or the substrate. All right, so we're talking about our activation energy barrier here. All right, and this is how much energy the reaction requires, okay? And so on this graph, we're gonna compare the energy that this reaction requires against time, how long the reaction takes to proceed, okay? And on this end of the graph, we have our reactants. That's what we're starting with. And on this end, we'll get our products, okay? Now, in the absence of an enzyme, that's the first curve we're going to draw. All right, let's draw our set point here for energy requirement. Right, that's standard. And so the reaction in the absence of an enzyme is going to proceed in this way. We're going to have to put in some energy here, and then after a certain time, we're going to yield our products, okay? And so this is how much energy we're going to have to put in or invest initially. This is called our activation energy. Okay, and then this is how much time it's going to take us to get from our reactants to products. All right, let's just make a little key here. So this is the reaction without the enzyme present. Let's look at what the reaction looks like with the enzyme present. So again, we're starting with reactants. And what we'll see here is that we don't need to invest as much energy and we don't take as much time. Okay, so at this point, we have our products. And this is all the energy that we required in order to conduct this reaction. So this is our activation energy again. Okay, and what we can see here, let's compare these at the bottom here, is that the time it took for the reaction to proceed in the absence of the enzyme is much longer than the time it took the reaction to proceed with the enzyme present. Okay, and let's sort of just make two notes here. Right, so from this graph, we can sort of deduce two general principles about enzymes. You see this? Okay. One is that enzymes lower the activation energy. Required. Okay, that's the first principle about enzymes. And the second one is that enzymes speed up the reaction. Okay, so this is the purpose of an enzyme. And this is why we have them in the body. And we find them in all different locations. And we're going to talk about some of the properties of enzymes today. We're going to talk about how they're regulated and how they are so specific, right? It takes a very specific substrate to bind to an enzyme and bring about a product. Okay? Any questions on this drawing? Any questions on this graph? Okay. All right, so this is a very similar graph to what we just drew. And again, the two principles that we're really illustrating here is that the enzyme will speed up the reaction, so it's going to take less time to occur, and it's also going to lower the amount of energy that's required, so it's going to be more likely, more favorable to occur.